So, folks, I think we're going to try and get started here. I don't want to waste 1 minute of the time we have together. First of all, good afternoon. Happy 2021, everyone, and welcome to the latest edition of Cup of Joe. My name is Kathy Barnard. I'm the Alumni Director for the University of Idaho and a proud Vandal alumna myself. And I am so glad so many of you could join us today. This is the largest audience we've had for a Cup of Joe since we started last March. So I'm so glad you could be here. It's going to be a good one. I want to give a special welcome to a few of our guests. And from my Brady Bunch view, I can't see all of you, but I'm hoping that everyone's on. We've got President Scott Green is going to be joining us today. Welcome, Scott. I'm so glad you could be here. Provost Tori Lawrence is with us today. Welcome, Tori.
Hello.
Hey, Tori. Mary Kay McFadden, Vice President for Advancement, and like Tom, a St. Mary's native. Go St. Mary's. She's here with us today. Thanks and welcome, Mary Kay. We have Engineering Dean Larry Stauffer is with us today, as is Science Dean Ginger Kearney. We've got our Athletic Director today, Terry Golick is here. Thanks for coming, Terry. I'm glad you could join us. And former Dean of Students, Bruce Pittman, is with us today. Thanks and welcome, Bruce. I'm glad you could be here as well. It's just wonderful to see so many familiar faces and a lot of new faces as well. It's going to be a great afternoon. I want to thank our program sponsor. Cup of Joe is sponsored by Payne West Insurance. Payne West is the leading broker in the Pacific Northwest where Vandals can shop for home insurance, auto insurance, and more. And every new policy purchase supports the U of I Alumni Association. And thanks to Payne West, everyone on this call is automatically enrolled into a drawing for a $50 gift card to the Vandal store. So we'll announce the winner at the end of the program. Must be present to win. So don't be checking out early. You got to be on the phone call to the very end to win. Before we get started, a couple of reminders. First of all, remember to put your mute on so your dogs or your spouse or your television doesn't interrupt what we're talking about. And as always, if you have questions, and I know that you're all going to have a lot of questions for Tom, please submit them via chat to my coworker, Christy. Christy, raise your hand. And we'll field as many of those as we possibly can in the time that we've got. It's now my pleasure and really a great honor to welcome Vandal Tom Mueller. I would say arguably one of the most impactful innovators of our time, and that's not an overstatement. He was born and raised in a logging family in St. Mary's, Idaho. He earned his Bachelor of Science degree in Mechanical Engineering from the University of Idaho in 1985. And we'll go into that story of how he ended up going to the U of I in just a little bit later in the program. He earned a Master of Science in Mechanical Engineering from Loyola Marymount University in 1992, and then spent 15 years as a rocket development engineer with TRW. In 2002, he joined Elon Musk and Chris Thompson to create what would become what we know today as SpaceX. He served as the company's Propulsion Chief Technology Officer until retiring just last November, so he's new to retirement. In addition to the degrees I've already mentioned, Tom also holds honorary doctorate degrees from the University of Idaho and Loyola Marymount. He also was inducted into the University of Idaho's Academy of Engineers in 2017, among many other awards. So welcome, Tom. We're so glad that you could be here with us today.
Thank you. It's great to be here.
Before we get started, I wanted to just do a quick COVID check-in. You and yours are okay during the pandemic, safe and healthy, I hope.
Yes, thank you. I hope everybody else here too is surviving this pandemic.
It's a weird time for sure.
Yes.
And the story of how you became a Vandal really is a compelling one. So let's tell it. What influenced you to become a Vandal and come to the University of Idaho?
Well, I was always interested in science and read a lot of science fiction and was very mechanically inclined, but I didn't even know what an engineer was. And I decided to take high school trig class, trigonometry. And my teacher, who's online here, Gary Hines, came up to me and said, "Hey, Tom, you're really good at math. You're going to be an engineer, right?" I said, "No, I'm going to be an aircraft mechanic." And he said, "Do you want to be the guy that fixes the plane or the guy that designs the plane?" And
Perfect.
so he explained to me that being an engineer, you'd be the guy that designs it. And he basically convinced me that I wanted to be a mechanical engineer. So I ended up taking my college prep classes and went to the university.
That's such a great story. And, it's how wonderful to have Gary here joining us. Gary, what did you see in Tom back then that prompted you to urge him to think bigger than being an airplane mechanic?
I think I unmuted myself.
Yes.
Well, it's not like I had a lesson plan that day to make this guy into a co-founder of SpaceX or anything like that. It was just a typical class. We would do our homework on the board with chalk, and then we'd introduce a new material. Then I'd spend the last 10 or 15 minutes walking around, seeing how the kids were doing with the next assignment. And I stopped at Tom's desk and just said, "Geez, you're really good. You should consider an engineering career." And that's when he said he had seen his counselor back in junior high that told him, "Don't go work in the woods or drive a logging truck. You should be an aircraft mechanic." And Tom said, "Well, that's safer than logging." And he's right. But I just said to him, "Well, do you want to be the guy that fixes a plane or the guy that designs a plane?" And I had no idea that just a comment like that would impact the way it did. And I'm so happy that he did that. And the most important thing to me, my wife and I didn't have any kids. So to hear from him after almost 40 years that he went through the effort to try to find me down, track me, and send me this wonderful message, it means so much to a teacher, especially an old one, to know you impacted someone in their life choices. And Tom's a special guy, and I'm proud of him and proud of our relationship, and the whole St. Mary's experience and my whole U of I experience has been a very happy one.
Well, first of all, I want to thank you for your role on behalf of the Vandal family for your part in this success story. And I want to give a big shout out really to all the Vandal educators. You make a difference in the lives of so many, and sometimes you don't even know it until many, many, many years later. So thank you, Gary. I'm glad you're here.
Well, thank you guys for hosting this, and I wish Tom with his new ventures, whatever they may be, all the very best. And if I could give him a hug and say thanks for remembering me after so long, it means so much to me, Tom. So
Thank you, Gary, because it, of course,
Yeah.
means so much to me that you set me on the right path.
Excellent. Excellent. So Tom, you got to campus, and what did you think? I mean, if you had you been to the campus before? Had you been on a college campus before?
The first time that I went to campus was actually, probably the summer before. I had to go to Moscow to take my ACT class. Actually,
Okay.
it was in the middle of the winter,
Oh my gosh.
and it snowed like 4 inches or 5 inches that night, and I had to get up early. And I was driving a Triumph Spitfire sports car,
Of course you were.
and I ended up in town, hit a van because I slid off the road, and the whole hood of my car was loose. So I'm driving to Moscow, thinking I'm going to be late for the ACT test, and the hood kept popping up as I was going faster. But I made it. I made it in time. Took the ACT, passed it, and got into school. So that was the first time I saw the campus. Of course, it was in the middle of winter. But then, starting school, it's a really nice campus, and I was in the dorms at Snow Hall, so meeting a lot of interesting people. But really, it was the coursework, that once you realize what engineering, how math can simulate, almost anything. Like if you know enough about it and know that the equations and the boundary conditions, you can simulate anything. And that's really an eye-opening realization as a young student, as an engineer, just like, wow, you can do that. You can use the energy method. You can use the dynamics and statics, or all these different techniques that it's almost like magic. Engineering is magic to the uninitiated.
Yeah, a whole new world for sure. So Who were your favorite professors, mentors when you went through the program?
Oh, there was the design professor who was quite a character, Jasper Avery,
Okay.
and I believe, fortunately, he's gone. He was really quite a character, and he took us. We did some of the tours. Went over to Boeing, the Boeing aircraft on the bus with him, and it was just a lot of fun. And then I remember a younger professor, Terry Precht, was really influential, really great guy. I got along well with him. He's just a really good teacher. There was others, I forget their names, it's been almost 40 years ago, but I must say, I don't think other than one calculus professor, I had all really good professors. Just
Well, there's
really
always going to
solid.
be that one, right? This guy.
Yeah.
Excellent. Were there any specific projects that you got a chance to work on that kind of gave you a glimpse at what your career turned into?
I think my my background, my dad being a logger, helping him, work on his equipment, welding on the bunks and of the logging truck and on the blade of the cat, things like that, where I got very hands-on. I think that gave me a really good base. I think that's something that's kind of missing a lot in school this day, more and more, where it's just become more of a digital age where people don't get the hands-on experience like I did, especially in that environment, like in the Idaho environment. I think there's still a lot of that with all the ranching and logging and mining and stuff that goes on still in Idaho. I think that's a good base to have, is that hands-on stuff. So there was a lot of projects. It's one of my other famous stories is I took the lawnmower apart and put it back together. Well, I had it apart. My dad came home from work and saw all the parts laying there on the lawn or on the driveway, and he was pretty mad because he didn't think I'd get it back together. And he said, "You're going to be mowing the lawn the rest of the life to pay for a new mower." And I got it back together, and it ran great. So that was a project that probably proved my acumen early on. But then, the science fair projects that I had in high school with Sam Cummings was, Idaho School Teacher of the Year, I think a few different times, because he really pushed the science. I went to the International Science Fair in Anaheim, California, my first trip to California, first time I ever flew in an airplane. So that was really cool. So those all really helped set me up, once I got into college.
That's awesome. That's awesome. How did you land that first job out of college? Did you know did you know exactly what you wanted to do and it came to you, or how did that unfold?
I did. I was always interested in rocket engines. I went to the International Science Fair in 1978 with a rocket engine project, in high school, as a junior in high school. So I had a couple job offers in the Pacific Northwest that weren't aerospace or rocket, so I turned them down. I didn't take them, and I told my dad and my mom, I said, I'm going to move to California where the rocket jobs are and get a job working on rockets. So everybody thought I was crazy, but it really panned out. So I started out at Hughes Aircraft, not on rockets, on spacecraft. But I was only there a couple of years, and then I went to TRW. TRW was where I became a propulsion development engineer, and I was there for 15 years. Started out as a propulsion development engineer, and then when I met Elon, I was the head of the propulsion department there, the manager of the propulsion department. And that's where I got to work with all modern propellants, some exotic propellants, solid rockets, gel rockets, liquid rockets, cryogenic engines. So I really had, and mostly working just R&D stuff for NASA and Air Force. So just a lot of different things. And that I think that gave me a really well-rounded rocket experience that when I met Elon, I was able to take that forward into SpaceX.
How did that time at TRW evolve into SpaceX? I mean, what was the, hey, I've got, it kind of makes me think of, the old Andy or Mickey Rooney, my uncle's got a barn and we've got some costumes we got to show. So
right.
Elon Musk and you, and how did that
well, actually, not getting my fill of rocket work at TRW, in 1990, me and another engineer at at TRW went and joined an amateur rocket club, Reaction Research Society. And so I was building liquid rockets as a hobby, and testing them and flying them on weekends. And it was actually through the amateur rocket club that I got introduced to Elon in January of 2002. And he was looking, he had famously now gone to Russia to try and launch a satellite to Mars on a Russian rocket, and got turned down basically by them, or they raised the price, and it didn't work out. So he decided to do his own launch vehicle company, and he asked these guys that I knew through the amateur rocket club. He said, I need a rocket engine guy. Do you know anybody? They said, yeah, you need to meet Tom Mueller. So that's how I got introduced to Elon.
Nice, excellent. And when you started, did you ever imagine that it would turn into what it has become today?
Not really. I mean, I knew it was a huge risk, whether we'd be successful or not. So it was a tough decision to leave TRW, where I had a good career, like basically the bird in the hand, versus two in the bush is kind of the situation. And but I knew I had to do it. But I knew that we were successful. Like no private company had ever developed a liquid rocket. So I knew if we were successful, it would be a big deal. Who knew it would be where we're at now? That it's been quite a ride.
Oh yeah, I mean, just amazing progress, amazing. Yeah, it's just been an incredible ride. One thing that's kind of the thread throughout your career, though, Tom, is you're in the innovation business, right? So where does the inspiration for your innovation come? Do you have a process? Do you keep a notepad? I know you said you read science fiction. Where does that inspiration come from?
I'm not very organized, but when I have ideas, I write them down, or I start. I'm a spreadsheet engineer. I used to do a lot of programming, but I kind of have gotten back to just doing spreadsheets. If I need to do programming, I do it in macros in Excel. But I do everything I start everything in Excel, and it's a very powerful tool, and it's very visual. You can see everything you're doing. You can graph it, and if you when you have employees, you can just give them your spreadsheet, and they can kind of give them some pointers and deconstruct it, where it's a little easier to hand it off as a spreadsheet than it is like as code. I've found, like, I have a lot of code that I wrote that nobody would want to touch, or it was very useful for me. But I found that spreadsheet engineering to start with was a great way to take your idea and expand it, and you can do optimizations, you can test things. So that's kind of the way I've been doing it. But along with that, I think I was always pretty optimistic. Like, I always was a can-do attitude, and I think that's what Elon really saw in me, and one of the main things he liked about me. And of course, I learned from Elon to be a real risk taker, like to think big and maximize everything, and take big steps. So I think I really developed it at SpaceX. It's quite a jump up from TRW into SpaceX. How not going from high school to college?
Yes, a very big step. A very big
Yes.
step. And really, today, I can't think of another corporation that's taking as big a steps as SpaceX is. That risk taking pays off in the long run, right?
Yeah. Yes.
That's awesome. So I know that we have some questions, Christy. We have a lot of questions, and just a reminder, folks, if you want to ask a question of Tom, please funnel it through Christy in the chat, and we'll field as many as we can. So I'm going to turn it over to her right now, and we'll try to get as many in as we possibly can. Christy?
Thank you. Tom, I just want to say that we have a lot of prospective engineering students on here that are coming to the U of I soon. And I want to thank you for writing notes to prospective students in St. Mary's. That was a great effort on your part and very impactful. And I just want to thank you for that.
Oh, you're welcome.
So how do you see Starlink affecting internet access to rural Idaho and rural America?
Well, I have a great Starlink story. I was visiting my sister the week before Christmas on Flathead Lake, Montana, outside of Folsom, and they have no cell service there, but at least my AT&T doesn't work there. But she had like a cellular network, and I got on it. I had to do something, and it was so slow, it was ridiculous. And I did a speed test, and it was 0.22 megabit download. And she happened to say, she goes, "Hey, I got my Starlink terminal today." And I go, "You have it here?" She goes, "Yeah." I go, "Plug it in." So she went and got it. And in about 10 minutes, we had it up and running. And it was 135 megabits down and like 30 megabits up. So it was 610 times faster. So she went from unable to stream anything. It would take an hour to like download a YouTube video, to being able to have two people in the house stream 4K. It was kind of like they upgraded that, in real time. So that's how much of a game changer Starlink is. It was really an eye opener. And now even in the time since then, because more and more satellites are coming online every day or every week, people are now getting 150 to 200 megabits down, which is is faster than most people have on cable or fiber in town. So it's absolutely a game changer. I think it's going to help bring the world out to the rest of the world. It's really awesome. Pretty proud of what they're doing there with that.
I've got rapid fire questions coming in. So what are your views on the engine Aerospike engine and why it hasn't gained traction when it potentially offers significant performance increases compared to conventional Bell design?
The Aerospikes look great on paper. The nozzle performance that was originally calculated wasn't quite as good as when they actually got tested as they had hoped, but it was still better than a conventional Bell nozzle. But the problem with Aerospikes is they have you just can't make them light. They have so you end up with a very low thrust to weight, which is really important for the other part of the rocket equation, the mass of the vehicle. There's two things. There's the performance of the engine and the mass of the vehicle. You want high performance and low mass. Well, an Aerospike has slightly higher performance, but pretty bad mass. The other problem that Aerospikes have is because it has an annular nozzle rather than just a cylindrical nozzle, you end up having a lot of wall to cool. So you have to use more film cooling, which causes your combustion performance to be lower. So what you gain in nozzle performance, you lose part of that in your combustion performance. And then with the weight, we've looked at it. I've looked at it when it's at KRW. We looked at it when we were at SpaceX. It has never really traded.
Okay. With the new types of propulsion drives beyond XIPS and large rockets.
Zips.
Okay. Zips. What will get us beyond Mars and not take generations of travel?
Well, so Zips is a xenon ion propulsion. So that's electric propulsion, which is what we have on Starlink. So I didn't know much about electric propulsion until I helped with the Starlink system. So I've learned a little bit about that now. But you need a lot of power to make electric propulsion work. So once we have a lot of power, like either huge arrays that are very lightweight to get solar power or nuclear power in space, you can move large things fast. The nice thing about electric propulsion is you can move stuff. You can get things a long ways over a lot of time. If you have years, you can get things going very fast. If you just want to get to Mars in 2 weeks, you don't have enough thrust. You just don't have the energy to do it. The way to get to Mars fast is nuclear thermal propulsion, where you just directly heat hydrogen on a nuclear core, on a nuclear reactor core, and that's at least double the performance of a chemical rocket. So there's a lot of work being done on that both with NASA and with the Air Force right now. So that'll be probably the next step. Then the warp drive.
So what inspired your recent move to retirement?
Well, it really kind of started back in 2014 when we were making a lot of Merlin 1D engines. That was the new design. We just completed qualification of that engine. The one that we're currently flying, the latest version of that is what we're currently flying. And we were trying to make, you know, up to 400 of those a year. And it became more of a production support role for me than it was development. So I told Elon and Gwen, I said, I don't want to do, I don't want to be the head of propulsion anymore. I want to go off and develop something. So they didn't let me step down immediately. We said we got to fly three of the new vehicles. So that's 10 engines with the Merlin 1D. So I came back like 6 months later and said, okay, we flew 3 rockets. So I'm ready to step down as VP. So I stepped down as VP, and that's when I was Propulsion CTO for about 5 years. And then my dad was very sick with Alzheimer's, and he ended up passing away about 4 years ago. So I went part-time in order to support my family. And once I went part-time with a company that's moving as fast as SpaceX, I really began to lose touch with the technology development and the program stuff. So it became harder and harder to stay on top of it. So then I went to just a year and a half ago, I went to just on call to an advisory role. And at some point, it just didn't make sense for me to still be attached to the company, because if you're either in or you're out, because it's too difficult to work remotely there and stay up to speed with what's going on. So we all agreed it's time for me to pack it in and go do something else. So last fall I got out.
All right, back to rockets. Not a rocket science question, but please ask Tom how, and more importantly, where he found the fountain of youth and his truly inspirational humility.
I guess it's just small town mannerisms.
Let's see. How does a company like SpaceX innovate so rapidly? What lessons can existing mid to large organizations learn from SpaceX in this area?
Have the boldest, most driven CEO and visionary in the world, first of all, and hire the best people. People always ask me, what's our secret? The secret is the best people. Like Elon was very good at recognizing talent and hired people that recognize talent. I feel like my group Propulsion was really strong. Just hired really smart people, trained them right, and it's hard to beat a small group of really smart people. And I think that's the key to success. And then innovation grows from that.
Yeah, that's good advice. The most amazing thing about the Merlin engine is its shockingly high thrust to weight ratio. What aspects of the project do you think allowed you to build such an innovative design?
I think going back to just a small dedicated team, I was always just extremely, I pushed really hard about weight. I was quite dissatisfied when I was at TRW about how if somebody gave you a spec, like this valve should weigh, no more than 5 pounds, that valve's going to weigh 5.2 pounds because you're not going to quite meet the spec. And spec design is bad. What I look at the design and maybe do a hand calc and think that this thing could weigh like 1.5 pounds. And then you do the finite element modeling and everything. And if I go into a presentation, first thing I'll say is it costs too much and it's too heavy to my team. And I said, go back and take some weight out of that. Like I look at the finite element results, I see a lot of green. It's like, that could be thinner. Like, why isn't that's showing some stress, or, if the deflections are very low, it's just like, I got the weight out. And then, with the Merlin 1D, we went phase shut off, got rid of main valves, we got rid of, we, we got rid of big joints and just got the weight out of the engine. It's really pretty remarkable. We got the thrust to weight to 200. And then the rest of the vehicle is very light. The structures team worked very efficiently to get the tankage and the rest of the structure extremely light. So when you have a very lightweight rocket, the engine mass really counts. So having a high thrust weight on the engine, that's why we have such good performance. You look at the size of that rocket and how much payload it can throw. It's really about the mass more than the ISP, or more than the engine performance. Although the engine performance is really good for a kerosene engine.
What was your favorite memory when working back in the early days of SpaceX?
Oh man, there's so many. I'll have to name a few. Like in Texas, we just, like first time we did big tests, and then we went to quadrilane for the Falcon 1, in the Pacific, in the South Pacific. Some great times there, especially when we got the first Falcon 1 to fly. Then, first time we launched Falcon 9, first time we went to the space station, first time we took crew up. So there's just too many, but lots of great memories. I was 18 and a half years at SpaceX, and several times a year we broke world records. So it was just unbelievable.
Yeah, it's amazing. So this is kind of a follow-up to that. What was it like working with Elon in the early days, and how did that change and develop as he began more and more ventures? And what personal projects have you worked on?
I've had a lot of good mentors in my life. The best mentor I ever had was Elon Musk. I learned to just optimize everything, just be bold, just get as much out of everything as you can, get the cost as low as possible, get the performance as high as possible, get the mass as low as possible. He was just really driven to just do the best, do it as fast as possible, and do it as low a cost as possible. And we just learned how to just do it really efficiently, and that's why SpaceX became the juggernaut that it is.
Sorry for the random. I'm trying to cluster the topics together, but they're just coming in randomly. So this one is not a question, but thanks for reinforcing spreadsheets and practically being useful.
I think with with all the different coding platforms and everything, that spreadsheets have fallen out of favor. But I'm old school, and I'm here to cheer them on.
Yeah, good for you. Old school. Good for old school. What advice do you have for current engineering students?
The advice I always give any student is be as lucky as me to do what you love. Like, do what you love, whether it's engineering or whatever you do what you love, be very optimistic about it, don't give up, and just go make it happen. I think I'm pretty much the model of that. Came from a small town, had no college influence, no education influence. Somehow, just by luck and self-drive, I was able to end up here. And you look back, like, how did I get here? I look back and I made the right decisions at the right time. Don't take the easy way out. Don't make a short-term decision. Like when I decided to not take a job in the Pacific Northwest or something I didn't like, that was a big move. That was like, I have a job. I'm right out of school. I can go work in Portland, Oregon on forklifts, or I can, delay it and go to California and hope that I get a job in aerospace. And I made the right decision. It's where I want to be long term.
Tom, we're having some audio problems, and I think everyone is muted except you and Christy.
That might be me because my maid is up there acting. Hold on, let me shut her off.
That'd be great. Thank you. I hate when that happens.
Yeah, where's my maid?
Should be better now.
Much
I
better.
picked the wrong
Thank
day
you.
to have the maid come in.
That's all right. That's all right. Much, much better. But you might want to repeat your advice to current engineering students because I think a lot of that got lost.
Oh, wow. So, you know, follow what you love. Be an optimist about it. Don't get easily discouraged. And you know, when you hit those forks in the road, take the harder one that gets you where you want to be later on. Don't look at your short-term gains. You know, get to where you want to be in the long term. Like when I, you know, took or turned down the job in the Pacific Northwest and decided I want to go work on rockets and move to California. So that was the right decision. It was a hard decision to make. Or like when I met Elon, it's like, wow, I'd really like to go do this thing. It's high risk, but it's where I want to be. So I left my career at TRW and went to SpaceX. So you know, you got to make those bold moves to end up where you want to be. And not all of them are going to work, but if just a few of them work in your lifetime, you end up in the right place.
Christy, you're on mute.
Yeah.
Sorry, I thought I was the one that had the vacuum going, so I muted myself. What is your view on the jump from your Merlin 1D engine on the Falcon 9 to the full flow Raptor engines for Starship? Will it be as reliable?
I think it's going to take some time to get it as reliable as the 1D because the 1D is just a much lower pressure engine. But certainly the performance advantage you get with that engine for going to Mars is going to be worth it. So it's going to take a while to get that thing robust. As the Merlin 1D is just, it's like I don't know, like I always called it like the Chevy small block engine of rocket engines. It's easy to make, it's cheap, and it's decent performance, and it's just super reliable. And you know, the Raptor's maybe a little bit more like a V12 Ferrari. So it's going to take a while to get it, you know, just really tuned in, but it's going to get there for sure.
Yeah. Okay, let me get. Did you ever feel like your degree from a land grant University of Idaho put you at a disadvantage from others and from more prestigious universities?
Not at all. No.
Good.
I'm kind of like, I've become kind of like Elon. I don't put a lot of weight on which, like if you came from a big school or not. That was never a factor for us. It's like he didn't care where our hires came from, whether they had a college degree or not. Just that they had done something extraordinary and were bright. And I think I got really a good hands-on education at University of Idaho that I might not have gotten at, you know, some much bigger school.
Yeah. Right. Someone spent several years in USSR Russia working for the government, wondering if you ever visited or know much about the Zhukovsky Cosmonaut Training Center.
Nope, never been to Russia. Nothing about it. I study their engines. They have great engines. Luckily, they patented the RD-180 engine, and we can look at the patent and see what they did. It's pretty remarkable stuff.
And someone just got their first rocket job software. Any advice for early space engineers like themselves?
The advice I gave: be an optimist. You know, do what you love and be optimistic about it. Be happy about it. Like, this is your career. If you're happy at work and like what you're doing, you will excel.
What risks are you planning to take now to pursue new life goals?
Well, I just bought a really fast race car. That's pretty risky.
Can you tell us more about that? You said that.
Yeah, I have a Porsche 911 GT3R race car, which is you know, one of the faster 911s that you can buy, pure race car. And then I just actually today completed the a buy on what's called a Jetta G57 prototype. So it's like all carbon fiber, crazy looking race car with a Corvette LS3 engine in it.
Wow.
Some people say it's the fastest car that a private person can own. So that's pretty
Wow.
risky.
That sounds fun.
It's really fun.
Yeah. Oh boy, I got so many. I'd love to hear Tom's thoughts on engine reliability in the era of reuse. What changes about the engine design when you hope to use it hundreds of times for tens of thousands of seconds? How confident are you that they hold up over the long haul?
You know, it's keep it as simple as you can, but it has to get complex in order to get the performance you need. And the example I would give is like triple spool modern aircraft engines, you know, turbojet engines. They're pretty complicated. They're pushing the temperatures and the pressures as high as they can, but they've had just a long time to develop that and make it right. And they're extremely reliable. They operate for a very long time. So you got to do the same thing for rocket engines. You have to understand the fatigue and vibration environments and reduce the thermal strain, because thermal strain is what breaks rocket engines. And once you understand that and fix, you just constantly fix those problems and dial it in. It's amazing how much time you can get out of a rocket engine. And then you make them easy to rebuild too. Like the Merlin 1D, you know, it's pretty easy to rebuild that engine.
Okay. There's many a shout out from St. Mary's people who are on the call today. They're very proud of their lumberjack.
I'm very proud of my hometown.
Any advice for motivating teams to reach for the stars, literally and figuratively?
Yeah, like I said, it's not just engineering. Like, do what you love. Like, I remember, you know, when I was in grade school and high school, my older brother never got great grades, and my dad would always say, "You need to be more like Tommy and get better grades. And what are you going to do?" And he liked He liked hunting and fishing, and you're not going to be able to have a career doing that. Oh yeah, my brother moved to Alaska and was a bear guide on Kodiak Island and a fishing guide on the Quacktalk River. So he made a career out of what he loved. That's what I'm saying. Just do what you love and be good at it. You can do anything.
Absolutely. All right. Do you see a future where Starship provides intercontinental travel in addition to interplanetary travel?
Absolutely.
Wow.
Yeah, pretty excited about that too.
How soon?
Starship is SpaceX so far has been evolutionary. Starship is revolutionary. It's a fully reusable vehicle that's designed to operate daily, like an airliner. It's going to change access to space. Like, people say, why do you need to take 150 tons to space, you know, for $5 million, say? Like, if the design ends up where it wants to be, like, say for $5 million, you could take 150 tons to space. What are you going to do with that? Well, it's like an IBM PC in 1984, or the internet in 1990, or an iPhone in 2007. What are you going to do with it? Or a smartphone in the early 2000s. What will you do with this thing? We don't even know yet. But we do know some things. You're going to exploit resources on the moon, water and minerals on the moon, mine asteroids, use that water to make propellant, use those minerals and metals to build structures in orbit and in the inner solar system, build gas stations throughout the inner solar system so you can transport, put giant solar PV arrays up there so you can have massive energy and move manufacturing into space, basically to save the planet, using the resources of the inner solar system to save the planet. So it's Starship, I think, is going to allow us to get to, you know, like a Star Trek type future. It's pretty amazing.
That's pretty cool. I have so many questions. Let's see. I mean, they're just coming and coming. How did you stay in the R&D technical side and not get pushed into a production or maintenance or become forced into logistical positions?
Man, it's just luck of the draw. When I hired into TRW, they were looking for somebody to take over from an engineer that just left on a NASA development program called OMV, Orbital Maneuvering Vehicle. And so I got into development on that, and some of the other engineers I was working with at the time were working on the satellite engines that TRW was using on their satellites, and they ended up getting into the production side, to where you know, kind of where I ended up with the Merlin engine. You build it, and you get it right. Once you get it developed, now you just got to make the same thing exactly over and over again, and that's where I kind of, you know, get bored. And so these guys were, you know, making engines like this one right here. Hang on a second.
I love the demonstrations.
That's a little satellite thruster from TRW that I was able to grab a hold of, and they just make, you know, 10 of those a year, very slowly, very carefully, test them and fly them. That wasn't for me. So luckily, I was my whole career at TRW, I was never on a flight program. In fact, the first hardware that I ever flew was a Merlin engine, and with a Kestrel on top. Yeah, none of the things I ever worked on at TRW ever made it to flight, which was a good thing.
So someone said, I grew up in St. Mary's, and I was wondering what advice Tom has for helping someone change his mindset into thinking big and doing big.
Well, I was never one for arguing until you're blue in the face. I was always more of a show by example. So I guess I give that example, or that advice. Do it more by example. Then if you can't convince them with reason, lead by example.
Yeah, great. Write that quote down, Sandy. Someone else said, I'm also from St. Mary's and spent 10 plus years as a welder fabricator. So I had a late start in my mechanical engineering degree, but I'm getting there. Do you think such a late start will hurt my chances of working for a company like SpaceX, or will the hands-on experience in that industry help?
Your age doesn't matter. You can start anytime. We hired people, you know, that were almost retirement age that took off and excelled from there, and they're still working there. So it's,
wow.
Age doesn't matter. It's never too late to start. I remember it's probably an example that a lot of people wouldn't understand, but like Humphrey Bogart didn't become an actor until he was into his 40s, and he was a famous, you know, actor from the 1900s. So it's never too late to start.
Yeah. And this must be from a student. I have been making homemade rocket fuel and reusable rocket motors from hardware stores like Home Depot for months now. I have been able to borrow a digital Newton scale from school, and I have recorded amazing thrust performance. However, only on my second time, the motor exploded, destroying the sensor. So my question is there any way to calculate theoretical thrust so I can eliminate the need for a sensor in the experimental stage?
Yeah, everything that I do is done experimentally first. So whether it's a solid rocket or a liquid rocket, there's design guides, and all of those propellants, you know, that you'd use have been characterized quite well. So you know the KN, the N, the AP, you know all these factors that you can design these engines with. And then if you're going to test rocket engines, you know, as an amateur, which I did a lot, just do it safely. Don't ever be near the thing when you test it. You know, be very safe about testing it.
Yeah.
After all the stuff I've done, I still have all my fingers, so I did it right.
In an industry like SpaceX, where the engineering must be developed with high accuracy and mathematically proven, you also have a world that is embracing artificial intelligence and machine learning to solve very complex problems. Do you know if SpaceX is going down that route for their research?
I don't know of too many things when I was there that were they're using like machine learning or AI, but that's not to say they're not doing it. It's just far away from kind of other end of the rocket from me, so I can't really speak for SpaceX on that.
Yeah. How did you stay technically savvy after school?
I got very technically savvy developing the liquid rockets. The nice thing about, like a lot of times you hear like an engineering student say, well, I learned all these different things. I only use, X and Y out of the whole alphabet. And the nice thing about liquid rockets is everything you learn as a mechanical engineer you use, because you have fluid dynamics, you have chemistry, combustion, heat transfer, high stresses, vibration, shock, some electric, some avionics, some control theory. So everything that you've learned in college you use, or as an engineer you use as a mechanical engineer. So it's really, I think mechanical engineering is is the best fit for rocket development engineers. Now I forget what the question was.
Oh, what was the question? How did you stay technically savvy after?
Yeah, so you use everything you learn, but then I found as I became a VP, where I used to joke to people would say, "You're really smart. You must have a PhD." And I go, "I have 7 PhDs." They go, "Really?" I go, "Yeah, I'm hiring another one next week." So you get to the point where the hard, like you do the spreadsheet engineering, and then you give it to your PhDs or your guys that are fresh outs, and they're gonna go program it in Python or something and make it happen. Then you start losing your skills. So I would do little exercises to try and keep them. And now that I've retired, I've just been going back to the basics and kind of relearning some of the stuff I forgot.
Yeah. What do you think about Starlink producing so much light pollution for both professional and amateur astronomers?
I think they've got some good solutions to that, and they've been very willing to work with the astronomers to make it better. It's never going to be perfect. Hopefully we do a better job than the other constellations do, and as good a job as possible, putting the visor on it, putting the the light blocking paint, and just working with them to make it as least interruptive as possible.
Yeah. Don Eddy wanted to say hello and let you know that he is a 1955 Idaho mechanical engineering graduate and fellow rocket scientist. He worked for Rockwell for 37 years and has worked with Blue Origin.
Oh, wow, cool.
Yeah, so that's kind of neat. When will Starlink be available to the general public? Not everyone in northern Idaho has internet.
Yeah, I don't know when I haven't heard anything about the general rollout. There's the beta testing right now, which a lot of people are able to get on. I think they stopped rolling out. But I think as we get, more and more launches, at some point they're gonna roll it out. And northern Idaho, where you're at, is really kind of the ideal band for getting early access. Like right about the borderline of the U.S. and Canada, over hundreds of miles. That's where all the satellites kind of congregate together as they come up to the northern end of their loop. It's very sparse over the equator. It's take a long time before you have good internet connection out in the middle of the Amazon jungle.
Yeah.
But right there in the Panhandle, it's going to be great. You're right in the right zone.
Christy, we've got time for one more question.
Okay.
I don't know where the time has gone, but we've got one more.
We're having too much fun.
So there's been a few questions about what is a realistic time frame for a manned mission to Mars.
Oh, that's an Elon question.
Okay, how about, does the future landscape for space travel belong to private industry, or is there room for collaboration between public and private organizations?
It's always collaboration. I think, that's what NASA's for, is to develop the science that industry takes and makes happen. So, a lot of our development money came, on doing the the COTS, the cargo dragon, and the Crew Dragon, and so there's just a lot of collaboration between us and the government. But I think really you don't want the government building the rockets. The government doesn't build doesn't build the aircraft. Like, you fly in a Boeing aircraft, not on a NASA aircraft when you travel. So it's really should be private industry that builds the rockets, and NASA that helps develop like NASA should be developing advanced propulsion, you know, bases on the moon, things like that.
Mhm. Okay, Kathy, turning it over to you.
Thanks, Christy, and thanks, Tom, for that was a wide range of questions in a very short amount of time. So thank you for that.
Nothing I'd rather talk about than rockets and race cars. So thank you.
That's awesome. So before we let Tom have the last word, I want to announce that drum roll. Janet Schomburg is the winner of our $50 gift card to the Vandal store. So congratulations, Janet. We'll get that into the mail for you. And then Tom, what final thoughts would you like to share with your fellow Vandals?
Well, I think it's in order to repeat myself, you know, do what you love, be an optimist, and if you just be even half as lucky as I can, or as I was, you'll have an awesome career.
It's awesome. What a great message to end on. Thank you again for your time. So appreciate it. Thanks to all of you for joining us today. What a great bunch of questions. We might, if we're going to keep having guests like Tom, we might end up having to make it a 2-hour program instead of an hour-long program. But I hope that you got your question answered if you asked one. We'll be back in February with another great guest. And as always, go Vandals.